Hi, welcome to another video of PLC programming. Today's video will be learning how to program unlock input and unlock output inside PLC. In our last video we learned how to program digital input and digital output. Today we'll be learning how to do programming unlock input and unlock output, also wiring in the PLC unlock input and output. What we're gonna do today, we're gonna simulate one joystick with one multimeter. So our input going to be joystick and output going to be a multimeter. Our input going to be 0 to 5 volt and our output going to be 0 to 10 volt is DC. Okay, let's start the program. Okay, so let's start wiring. First we need to set up our PLC. Let it power down. So let's say we're going to install this analog output module in the controller. So this will give us analog output. Then we need to connect this joystick. This joystick has one axis, okay, then one push button. So let's wire the joystick in the PLC. We need to give, this is 24 volt, not negative. This is signal analog 0 to 10 volt and this is one switch. Okay, so we're gonna wire this. Actually I'm gonna use power output from the PLC itself to get 24 volt in the joystick. Okay, that's ready. Now we'll connect this analog input to analog input 1. Okay, now we need 124 volt. Okay, we can take it from the supply side. This will be going to our digital input number 1, that's our digital input 2. Okay, 0.1, that is our second digital input. Okay, so now we wire up. Okay, now the wiring is ready. Just power up. And make a small function test. Actually you cannot see analog input here in any light. Digital input all you can see. So you can see the button is working, so this should work. Now we'll go inside and see how inside the program is working. Okay. Let's start programming. Now this is our last program, a digital input and a digital output. So now we're gonna add one analog input and one analog output. So first what we're gonna do, we bring our joystick, this is 0 to 10 volt to 0 to 100%, and we send back this to analog output for 0 to 10 volt output. Okay, so we have 0 to 10 volt input, 0 to 10 volt output. So now we need to program that to happen, because you have input connected to joystick and to the controller, and the output needs to go from the controller. Let's start with the program. Before we start the program, we add one data block where we will set a set of values these are analog data. So we make a calibration. It's a 2-point calibration kind of thing we're gonna make here. What is okay, I didn't explain you what is this data block. Data blocks are a kind of database what we have in the PLC, where we store the data and process the data from there. So basically when we have some tagging for big project, we'll be adding in the data block to identify them. So our analog data will be adding in this data block, and we will say AI roaming, AI row max. This is row minimum, row maximum, analog input. Then AI norm x, then AI cal min, AI cal max. So this is calibration minimum and calibration maximum. Then we have our analog output, AO row min, AO row max, then AO norm x, then AO cal min, AO cal max. So these are minimum maximum calibration. You have this 2-point calibration, so you need a calibration raw minimum maximum value and a calibration minimum maximum value. This is how you see, like Rixense or wherever you calibrating, you have this 4 value to put. So this is same thing we're gonna program in the PLC. So let's start programming. Now we will be okay. We will do one thing. We will not okay, we'll be start doing here. Okay, so we say block called normax, then we call one block called scale x. Okay, then we take our analog input. This is %IW 64. Here you can see that this is our analog input and this is our analog output. Okay, so this we gonna do, so analog input, then this we gonna choose here analog data, sorry, analog data, sorry, because this is need to be real, then this need to be real, then you need to come here again. Okay, sorry, because I made a mistake here. This all data need to be real. Okay, this real is a type of analog data. So we have different data type. It is integer, you can see here. You have a set of thing you can put here, but we normally use real for analog data. Okay, you can use also weight in some cases, but I use real data. So now we need so this first block we're doing to normalize, and second one we're gonna scale. So here we need to put the raw input. I will say raw minimum and raw maximum, and output going to normax out. This is AI normax. Then this one again going here, input for the scale x. Then the scale x we're gonna use cal minimum and we're gonna use cal maximum. Now we need to have one output. This is our real output of joystick position. We say joystick position. Okay, so now you come here, you take your joystick position. Okay, so the program is finished. So you bring your analog input value, and you made min max, and you made calibration minimum, calibration max, and going out. So now I write here a joystick like a strange. Okay, now it's okay. Okay, now load the program to controller. I did a software roll. We don't need actually software roll. So our joystick is 0 to 10 volt, and now it's in the middle position. So how this working in Siemens, we have 4 to 20 milliamps is, let's say 0 to 20 milliamps is starting from 0 to 2750. This is the number. So when you have 20 milliamps, it will be 27500, and when it is in 0, it's 0. Same for analog input 0 to 10 volt. We should have a minimum, let's say half of this. So 27500 divided by 2 is 13750. So we have 0 for calibrate raw minimum, and our raw maximum should be 13750, and we need to have our joystick full position to 100. Okay, so now you can see your analog output joystick. We made the calibration, so this is our joystick calibration completed. Now we have 50% because our joystick staying in half position. Now I will move the joystick to 0 and 100 position, and you will see it's changing there. So moving to one direction, it is 100, and moving to another, it is coming to 10%. So when the joystick is minimum, we are seeing a number of 1399. So we need to give that to 1399 as our, no, actually we don't need to give that. No, we don't need to give that. We don't need to give that. Only we need to make sure how much is coming. This is your full position, 12423. So now we need to give here 12425, and it's changing here because this joystick is not giving exactly same number of 0 to 10 volt. So this is in, okay, now we have 100%, and okay, we have here is our problem. So okay, now we need to give 1399 as 0 position. as 0 position. Okay, so why it's happening, we need to figure out. Take the multimeter and look with multimeter. This is 2.4 volt. Okay, this is 4.5 volt, 0.5 volt. Okay, you can see here, this is, okay, when I move this, it's going to 0. So So 2.5 volts, 0.5 volt is our minimum position, 4.5 volt our full position. So this is not 0 to 10 volts, this is actually 0 to 5 volt joystick. Okay, so that's why we have this reading here. So we have 0.5 volt, that is 1399, then 12425, this is 4 point some volt there. This is not exactly 5 volt, close to 5 volt there. So now our joystick position is 9900. Okay, so we have now joystick calibration completed. Now we're gonna do analog output, giving the analog output. So we have 0 to 5 volt input, we will be converting back that to 0 to 10 volt. Okay, so this we need to use Normax again. Scale X again. Okay, so this is our analog input and this is our analog output. Okay, so now what we need is this joystick value we will give here, then our raw maximum will be giving our curl minimum, curl maximum, raw minimum, raw maximum, then analog output Normax, same we need to copy. Okay, then our output is what? As our output is QW80. Okay, so we write directly back to percentage QW80. Okay, so now we program our analog output with 2-point scaling. Now download this to the controller. Okay, this controller, so it's showing 50. So now we need to make calibration. Here is 0, here is 100%, here is 0, here is 0 to 10 volt. 0 to 10 volt, actually we have there plus or minus, wait a moment, we have here a analog output module is plus or minus 10 volts, so we need to give only the positive side. Let's see, we need to make some work out there. So 27,500 divided by 2, let's try like this, 13,750, then we give 27,500. Let's see this can work. So this is giving 20, that's how many volts? That's 7.45 volts. That is 7.45 volts. Okay, that's okay. No, that shouldn't be okay. Let's calculate. Let me make a study here. Okay, there is 4.9 volts, so we need to give 0. Let's try 0. Oh, don't break my connectors. I'm a little bit strange guy with playing with PLCs. So because this is too hard to move. Okay, this is one side, is okay. Zero volts, okay. Okay, so you can see here. You can see here now the joystick in the middle position is 5 volts, and joystick moving to 0 position is 0 volts, moving to full position is 10 volts. So this is how we calibrate, this is how we make calibration inside the PLC for analog input and analog output. So this is how we're processing. So the process here I will explain one more time. You have your analog input, you calibrated this to 0 to 100%, then you took that 0 to 100% to 0 to 10 volt analog output. So your 0 to 5 volt analog input you converted back to 0 to 10 volt output. So you say you operating this joystick with one proportional solenoid. This is how analog input and analog output working inside the PLC. Okay, that's all for today's video. Thank you.